Hello everyone. Today I'm going to talk to you about the hygienic design of equipment with the food industry and why it's important. And what is hygienic design? Well, according to EHAGE, which is the European Hygiene Engineering Design Group, hygienic design refers to design selection of materials and surface roughness that satisfy strict standards for cleanliness and are used in the food or pharmaceutical industries. Basically, it covers everything that can be used to make equipment that will be used within the food industry and that complies with the legislation. What does it cover? It covers surfaces, both food and non-food contact, and their anticipated operating conditions. The materials, they need to be absorbent or not, and non-toxic without having to be dismantled. Cleanable, either clean out of place or clean in place, COP or CIP. They need to prevent the ingress and or growth of microorganisms or reduce the risk of contamination by microorganisms. With pests, it's the ingress of it or infestation, so they need to be able to prevent that. You need to govern particulates, so wear and breakages of parts leading to contamination. So if you've got two surfaces to rub against each other, you need to make sure that they don't generate fines. Conditions for intended use, so all normal or reasonably expected conditions that you're going to use them. Are they going to be class 1 equipment, which is cleaned in place, as in you don't dismantle it? It's things like dairies and breweries. Class 2, which is cleaned out of place, which is where you're able to dismantle it and strip it down, things like equipment in, say, sandwich factories or bakeries or potato processing factories, for example. They need to be resistant to chemical contamination, or they're designed to prevent chemical contamination, and compatible with other requirements. So designed but not able to perform to the requirements of ATEX or the EU Machinery Directive. Why is this important? Well, the BRCGS Issue 8 top 5 areas for non-conformances are Clause 4.11.1 Premises and Equipment Hygiene, 4.6.1 Equipment Construction and Maintenance, 4.4.8 Doors, big one there, 4 is Hazard Identification, and 5 is 1.1.2 Culture. I will cover all of these in this brief presentation to give you a flavor of why they're so important. So 4.11.1 states the premises and equipment shall be maintained in a clean and hygienic condition. It is important that the site, manufacturing environment and equipment are routinely cleaned to an appropriate standard of cleanliness to prevent potential contamination, e.g. with allergens or microorganisms, and to prevent quality issues such as taint from previously manufactured products. So how do we make this happen? So ideally, you need to be looking for the EHEG or the A3 logo when sourcing materials for your factory. So walls, they must be light colored, dense, tough and impact resisting, durable, rust-proof and dust-proof, and be able to withstand the cleaning chemicals and methods used within the food industry. They also must be impervious, non-absorbent, washable, water repellent, and constructed from non-toxic materials. Fairly simple when you think about it. Floors provide the foundation for safe, hygienic food production in factories. This is what you stand on every day. The hygienic design and installation of floors to ensure the correct level of ongoing hygiene is thus critical and must be undertaken as part of an integrated plan. Floors are critical areas. For example, they are places where Listeria monocytogenes are likely to be found and where bacteria could persist despite cleaning and disinfection. And slipping accidents correspond to around about 20% of workplace injuries. So for these reasons, slip resistance and hygiene are mandatory. According to EC Regulation 852/2000 on floor, I quote, floor surfaces are to be maintained in a sound condition and be easy to clean and when necessary to disinfect. Drainage of effluents generated in a food production process is critical for any building, especially so in relation to food production. Drainage should be considered holistically from a site perspective, as the site and each subsequent level of analysis has potential impact on hygienic operation. And the drainage system can either be a point or a linear drainage system or a combination of the two, depending on the actual circumstances and designed in accordance with EN 12056. Doors play an integral role in the building design by helping to segregate production areas while presenting a barrier to contamination such as dirt, insects and other pests and vermin. However, as food products have to move through doors, there is a possibility that contamination can drain, drip, diffuse, or be drawn into the production from door surfaces. Doors must therefore be hygienically designed. So doors should be easy to clean and when necessary to disinfect. Doors should have a good inspection access. Doors should be self-closing and equipped with kick plates and push plates. Sliding doors should have all gaps closed between the door and the frame and closed with gaskets of rubber or bush strips, but no bush strips in high hygiene areas. So here's a couple of illustrations of hygienic walls. The one on the left is a white panel wall going into a green floor, and one on the right, a white panel floor, part paneled with stainless steel going into a red floor. Both of these are wonderful examples of a hygienic wall surface. However, you then get the opposite side of this, where you have pipework going through walls which would appear to have been mismatched, or even corrugated steel walls where you can see they don't meet, they're going down to a tiled floor. Again, very bad examples of what not to do with wall designing and building. And if we were to look at floors and drains, the one on the right is a non-porous resin-coated floor, and there are many colors and grades available, and it can be non-slip to smooth depending on the environment it's to be used. And the one on the left is porous floor, which hasn't been suitably coated, that you can see is cracked. So we have a good example and a bad example. And when it comes to things like drain covers, you've got two examples of drain covers on this slide. The first one is a 3-slot drain cover, which is removable from a pot drain. And the one on the right is a ladder type drain cover, which you will find in the EHEG guidelines, is recommended because it stops product being adhering to it and it allows maximum flow through into the drain below. But choice of drains and drain covers is entirely down to the individual site as to what they want to do, but equally it needs to be hygienically designed. And if you look at 4.6.1 equipment construction and maintenance, this is all equipment shall be constructed of appropriate materials. So before any new equipment is purchased, its intended use should be fully specified so that the equipment can be suitably designed and made of much appropriate materials. This must include consideration of effective cleaning at appropriate frequencies, i.e., is it easy to be dismantled and has it been designed to be dismantled? And documented evidence should be available to confirm commissioning prior to its use. In order to facilitate routine cleaning, operation, inspection and servicing equipment must be appropriately positioned. Don't put your piece of equipment over a drain. How many times have you seen that happen? And it should be appropriately secured and sealed to the floor to prevent the accumulation of food debris underneath it where it cannot be cleaned. And it has been well documented that where equivalent of equipment or fixtures allow organic matter and or pathogens to collect and survive, this can subsequently cause product contamination as pathogens such as Salmonella and Listeria can survive for prolonged periods in these conditions if left undisturbed. So it's not just the BRCGS clause 4.6.1 that we need to worry about. There are EU regulations for use of food contact materials. So there's 852 2004, 1935 2004, and 2002 72. These govern what you can and cannot use. So you've got materials and articles intended to come in contact with food. They mustn't endanger human health or bring about unacceptable change in the composition of food or bring about a deterioration in the organoleptic characteristics of the food. And Directive 2002/72 gives a list of monomers and additives that you can use within the food industry. In addition, there is Regulation 23/2006 on good manufacturing practice for materials and articles coming into contact with food. EN 1672-2, Directive on corrosion being non-toxic and non-absorbing. Directive 2002/72 on what types of plastic materials and articles you can use. And 450/2009 on active intelligent articles intended to come in contact with food. And an intelligent article is any article that is designed to enhance the shelf life of a product. So there's a number. There are just these three are just a number of issues that need to be considered when sourcing or purchasing equipment. So we've got welds, chemical compatibility, and cleaning compatibility. These three images, if you look at image 1, you have a rough surface that hasn't been cleaned. It's not been smoothed off. It's a perfect place for the adherence of bacteria. Image 2 is a weld that has been cleaned off. It's smooth and it's not very good for adhering bacteria. And image 3 has been spot welded, where you have a piece of mesh spot welded to a plate, which is the worst of the three options because you've got areas between where the mesh meets the plate that's not been welded. So you've got gaps. Where you've got gaps, you've got bacteria. Where you've got bacteria, you've got product contamination. And where you've got product contamination, you've got loss of profitability. You've then got to look at things like chemical compatibility. This image shows signs of chemical corrosion. Now, ideally, you're looking for products that are made out of 316L stainless steel. Now, you have EN 1.4404 316L, which contains 70% chromium, 12% nickel, and 2% molybdenum. Or you have EN 1.4435 316L, which contains 18% chromium, 14% nickel, and 3% molybdenum. However, what you don't want is 304 or EN 1.4301, which contains 18% chromium and 10% nickel and no molybdenum. Alternatively, you don't want aluminium, as this is susceptible to attack by both alkalis and acids that are used in the food industry. There have been numbers of occasions where I've been onto sites where they have a site has purchased a piece of equipment and they were told it was 316L, and within a couple of weeks it was evident that it wasn't. It started to corrode and was going white and powdery. And then when you're looking at maintenance and cleanability, this image shows frayed edges of on a conveyor belt. And if you notice that the conveyor belt has a rough surface, so it makes it difficult to clean. And this belt is not a sealed laminate, so it's going to fray. Now, a couple of us here at Camden, we've written a paper covering conveyor selection and cleaning, which is currently in the process of being published. So hopefully it won't be too long. But if you look at these examples of a piece of equipment that is really easy to clean, because if you notice the bolts sit on plastic washers to ensure no metal to metal contacts, therefore no, and if you look at the one on the right, the strip curtain has a quick release mechanism, so you can take it out to clean it, and it aids maintenance. So both of these are from pieces of equipment that have been appropriately hygienically designed. And doors are, as I said, one of the biggest issues when it comes to non-conformances in BRCGS 8. They need to be fit for purpose, and you need to be able to maintain them. Now, if we were to look at the next slide, you can see there are 3 doors. The one on the left, the base of the door doesn't meet the floor. Now, this is an automatic concertina type door to the outside, but does not fit to the floor, which then becomes a risk for possible pest ingress, not particularly well designed. The one in the middle is a concertina roller shutter door, which is fixed, which is sealed all the way around. It's a partition between 2 rooms within a factory. And the one on the right is an internal flap door, which has lower protection due to the movement of plant through them. This you could typically call these 2 large areas kick plates, but again, it's a nice hygienically designed door. It's self-sealing as well, so it ticks all the boxes. And the fourth biggest non-conformity within BRC GS8 is hazard identification, and this is mentioned in Clause 2, which states a fully implemented and effective food safety plan incorporating Codex Alimentarius HACCP principles needs to be in place. And 4.6, equipment. So when the HACCP, it needs to include hazards relating to equipment design, cleaning, location, or maintenance, not just the controls of bacteria and or foreign bodies. And the BRC GS8 interpretation guide says that consideration must be given to all the sources of potential hazards. These could include raw materials, processes, and factory environment. And the process flow diagram is a useful tool in considering the potential risks at each stage of production. And appropriate measures must be in place to control them. And this goes back to the equipment design and construction. And with 4.6 equipment, suitability of equipment for its intended purpose includes its condition so it does not pose a product contamination hazard, its ability to be effectively cleaned, and its capability of producing safe food products. So hygienic design isn't just, something we've got to do. It's something that you must do. It's very big within food. And the fifth one is culture. But, how do you instill culture into an organization? 1.1.2 states that a proactive, positive culture within the company can make all the difference in the effectiveness of food safety and quality plan and its consistent implementation throughout the site. And this covers all aspects of production and people. And culture is also mentioned in a section called about temporary repairs, which is clause 4.7.3. Such things as temporary repairs or sticky plaster engineering. In an organization with a strong food safety culture, production staff should be knowledgeable about food safety and be empowered and feel ownership of compliance with the standard so that they feel confident about informing the relevant individual or department when a repair or adjustment needs to be made. So when it comes to temporary repairs, ideally it should be repaired properly first time, but we all know that this isn't always possible. So thank you for taking the time to watch my presentation. And for further information, please feel free to contact me on 0792 077 624 or at nigel.blitz@camdenbri.co.uk. Thank you.